and today we are going to move to the function with the 3 variables and see if function has a 3 variables, how you could use the K-map. So let's start with one example for the function with 3 variables. So suppose you have these function. The function f is the function with 3 variables. So we could label that x, y, z. So the function wrote in the standard form, which is the sigma m 0, 1, 4, 6, and 7. Okay, so you have this function that is in standard form. So the question is use the K-map and simplify these function. So this will be exactly the same with the K-map for 2 variable with just very small changes. So whenever your function has 3 variables, definitely you have 2 power 3 midterm or max term, right? So that means your K-map should has 8 square. Okay, so that means that if you want to draw the K-map, so you will have a table like this. So usually you put the first variable here and 2 others in the other side. So the x, you could say here the x could be 0 and 1, and yz could be 4 different bit pattern. You put 0, 0 here, you put 0, 1 here. So you put 1, 1 here, and 1, 0 here. Okay. So similar with the 2 variable, each of these square in the K-map is represent the midterm, one midterm. So see here, x is 0, yz is 0, 0. So that means this first square that you see is the midterm 0. Okay. So this should be midterm 0. We just put the 0 here. So the next one, x is 0, the y is 0. Okay, so we have a question, so that I check that. This is 3 variables. Yes, this is 3 variables. So see, the f that we have is x, y, z. So let's back here. So let I do one thing. So it is actually good to have, I add one title here, K-map. So for K-map for function with 3 variables. 3 variables. Okay, so which is somehow is clear, right? Whenever I write f, x, y, z, so it means this is the function with 3 variables. So you have the K-map with 8 squares. So this one is 0. What is the next? Let me to finish these numbers for each is the square that you see. So this is x is 0, 0, 0. This is 0. How about this? X is 0, y is 0, z is 1. It should be 1. How about this? This should be 3y, x is 0, y, z is 1 and 1. And how about this? It should be 2, right? X is 0, y is 1, z is 0. So back here, so the x is 1 and the yz is 0. So definitely it should be 4. Should be 4. So again, from the order you see here, you could understand the z is 1, this is 2, this is 4. Okay. So next here you have x is 1, yz is 0, 1, so definitely should be 4 plus 1, which is 5. So for this, x is 1 and yz is 1, 1, this is 7. And finally, this one, the x is 1, which is 4, you have 2, and z is 0, so it should be 6, okay? 0, 1, 3, 2, 4, 5, 6, 7, okay? So now, similar with the function with two variables back here and check the standard form. So here you have the midterm 0, so that means the function in midterm 0 is 1, so I put 1 here, is midterm 1, so see here 1, then you have 4, you just write the 4 here, sorry, 1 in the midterm 4, then you have the 6, so 6 should be 1, and the 7, which should be 1. We already mentioned in this midterm, in the midterm, the function value is 1. So that's the reason you put 1 here in the corresponding midterm. So then similar with the two variables. So the rule is this. You actually find these ones which they are neighbor, and you need to group them. So for grouping them, this is a rule. The number of the group should be minimum, and their members should be maximum. Okay. So just be careful whenever you want to make the groups. You start, as I mentioned in our last class, the members could have one member. The group could has 2 members, could has 4, could has 5, sorry, not 5, so 8, could has 16, 32, all the time should be 2 power n, okay? So that means the first thing you need to check the group with the maximum, the biggest members you could have is just 8, right? Because the total of the square that you have is 8. So that means you start with check the group with the 8 members, the maximum possible members that you could have inside the group. So you check the groups with 8 members. Do we have could we set any groups here or select the groups with 8 members? Yes or no? Type on the chat box. The group with the 8 members. So the answer is no. Why? If I had 1 here, 1 here, 1 here, yes, you could actually select one group with the 8 members. But you don't have 1 here, 1 here, and 1 here, okay? You need to just put these ones that you see in the map inside the group, okay? So here, the 2 doesn't have 1 inside, the 3 doesn't have 1, and there is no 1 here. You couldn't select actually the one group with 8 members, so you refuse that. Then you check the group with the 4 members. Could I actually select the group with the 4 members? Yes or no? So see here, let I just give you one example. So this is what we have, okay? This is what we have. This is our table. So we have 1 here, 1 here, 1 here, 1 here, and 1. Okay. So whenever you are grouping these one, so the all member in the group, they should be actually neighbor to each other or adjacent to each other. Okay. So that means if I have 1 here, for example, you could say whatever you have in this side of the map is the adjacent or neighbor with the other side, other one that you have. That means you consider this like this one, which is the cylinder. So that means whatever you have here somehow is connected to the other side. So that means you could say this one is neighbor with this one. You consider these shapes. So then you could say, okay, this one is adjacent with this one, okay? So, but here we don't have 1 here. I couldn't say these 2 is the neighbor with these 2 and they could make one group with the 4 members. So that's not right, okay? So if I had 1 here, for example, I could say, okay, these are the neighbor and I could group these 4 as a 1 group with 4 members. So as you could see here, we don't have 1 here. It is impossible to make the member with the group with 4 members. We don't have 1. If we had 1 here, you could say these two with these two is 1 group with 2 members. So that means there is no possibility to make a group with 4 members. Then you go and the small number, which is 2. So the question is, do we have any group with the 2 members? Yes or no? Yes, definitely we have. So let's just select that 2 groups. So again, the number of the group should be minimum and their number should be maximum, which is we couldn't make 4 and 8, so that's the reason we just check 2. So how many we could make? So see, you need to cover all these all these ones should be inside the groups. So I select this, could be a 1 group of 2. I select this as a 1 group of 2. These 2 is a neighbor, right? These 2 is a neighbor. So, and I select this. So see, this is, be careful. You couldn't select these as a 1. If you select these as a 1, so you have 3 groups, okay? 3 groups. 2 of them has 2 and 1 is 1. It is not leading you to the simplest form. Why? Because the number of the group should be the minimum and the member should be maximum. So that means the right way is this. So that means make 3 groups of 2 members, okay? So see, 3 groups is here is 3. Their member is, the member is 2 for each of them. So if you do this, 3 groups, and the member will be 2 with 2 members and 1 with 1 member, it is actually, it's not leading you to the simplest form. Why? Because then the members inside the group should be the maximum. So that means this is the right actually choose. So this one is not leading you to the simplest form because here one of that group has 1 member, okay? But here all that 3 has a 2 member, okay? So all the time, this is a rule. The minimum number of the group and their member should be maximum, okay? So then the next step is, right, for each of these group you selected here, you could have the corresponding terms, okay? It is equal to. So let's see how I'm writing the corresponding term for these group that you see. You just check it, it's x. So see, x is 1 for these member, x is 1 for these member. So whenever it is 1 and 1, it's not getting the prime. You write the variable, okay? How about yz? So see, yz, you check the y. Here in 7, the y is 1. Here again is 1. Whenever it is 1 and 1, the variable don't get the prime. So that means I have y here, okay? So how about z? So here for the 7, the z is 1, and for the 6 is 0. Whenever it change 1 to 0 or 0, 1, you eliminate that element. So that means for this term, there is no z plus. Write the corresponding term for this group of 4 and 0. So again, you move here in this member, x is 0, in this member is 1. 0, 1, you don't have that variable. So that means corresponding term, there is no x inside that. How about yz? So here the y is 0, here y is 0. Whenever it is 0, 0, you got the prime. And how about z? So here again z is 0, here again z is 0. So z get the prime. So z get the prime. So it is y prime, z prime. And the last one should be the corresponding term for this group that you see, group of min terms 0 and 1. So again, check the x. So here x is 0, here x is 0. So you will have x prime. So how about y? Y here is 0, here is 0, get the prime, y prime. How about z? Z here is 0, here is 1, 0, 1. You don't have any that variable, which is no z on the corresponding term. So I mentioned to that here, so I summarized that for you in our last class. 0, 0, get the prime, 1, 1, no prime, 0, 1, 1 to 0, you delete or eliminate the variable. This is exactly the same rule that I follow, okay? So now, if someone did the right choose, so that means if you did this, I just want to show how you end up with not wrong answer. We could say it's not the simplest form, okay? So suppose you did this. Suppose we have 1 here, 1 here, 1 here, and 2, 1 here, okay? If you did a mistake whenever you select the group, so suppose you did this. So you did this, you select this group, which is the right, then you select this, and you select this, okay, which as I mentioned, this is exactly this case, and this is wrong. Why? Because the number of the group is same with what we did here, but their member is not the maximum. Here, this group has 2, but here one of your group has 1. So let I write the corresponding terms so for this wrong selection. Let's see what's happened. So the first sentence is the same, which is the x, y, no change on that. So just make sure which is which. So the corresponding term for this is x prime, y prime, which is the last one. So that means the first term is same, y prime, z prime is same because we select the same thing. Yeah, let I rearrange this. So z prime plus. So that means you did this is the right selection. This is the right selection. That means these two parties exactly same with what you have here. And right now I'm writing the corresponding term for these wrong groups. So here you have x is 0, 1. Here is y 0, which is 0, 0 here, 0, 1 here, 1, 1 here, and 1, 0 here. So as I mentioned already, so if you don't keep in this order, it is right, you end up with the different answer, but I tell you how you could know the answer is right or wrong. For now, because I want to all of us get the same thing, you just follow exactly the same K map that we have. 0, 1 here, 0, 0, 0, 1, 1, 1, 1, 0 here, okay? So back here, if you select this, that means you say, okay, I have 3 groups, but one of them has 1, not 2. So let's see if I write the corresponding term for these wrong selection, what I will get. So x is 0 here, so you got x prime, and y is 0 for this group with 1 member, you got y prime, and the z is 1 for this group, so again you got z, okay? So as I mentioned, this is not the wrong answer. So this is the simplest, more simple form of what you see here, but this is not the simplest form. This is the simplest form. Why? Let's check that. So for this form, how many AND gate do you need for implement this function that you see? Tell me the number of the AND we need to implement this function, and how many OR we need. So we need actually how many and, you just see how many and do you have. 1, 2, 3, right? 3 and. How many OR do we need? How many of OR? So you only have 1, 2, right? You have 2. Even if you need the not, let's to add the not to, okay? Not. How many not do we need? So 1, 2, 3, 4, right? So not, so see you have y prime, definitely you have y, you need to take a not of that, right? So you need actually 4. I summarize all of them for these 4, okay? So then I summarize the same thing for this, and, or, not. How many OR we need for this one? How many OR for this? How many OR? 2, right? How many AND? 4, yeah, that's right. How many AND is 4, right? How many NOT? Again, is 4, okay? Compare these two. Compare this with this. So the AND is 3 here. This is 4. So the OR is 2 is right, and NOT is 4. So that means these, if the number of the groups is not minimum and the member is not maximum, the form that you get is not the simplest form. As you could see here, the simplest form of this function is this, which is just 3 AND, 2 OR, and 4 NOT, okay? So just understand why we have these rule, why the number of, because each group is corresponding to one term, right? So that means whenever we say number of the group minimum, that means the terms is minimum, right? So whenever we say number of the member inside the group should be maximum, because whenever you have the maximum number, its term has less variable, okay, has less variable. So see, so whenever the group with one inside that give you the terms with 3 variables, x, y prime, x prime, y prime, z. But whenever you have 2 member inside that group, it just gives you just one term with the 2 variable. So that's why the member should be maximum, because it's actually somehow eliminates some of the variables that you have. So that means if you have the wrong selection, you are not getting the simplest form of the function. You couldn't say this is the simplest form. So if you follow that rule, so that means the number of the group minimum and the members maximum, so then you could actually claim this form that you have is the simplest form of this function, and you couldn't get more simplest form of the function, okay? You have the function with 3 variables. It is in the standard form. The question is using the K-map and get the simplest form of the function. The function has 3 variables, so the K-map has 8 square. So you actually make the K-map. So you put the bit with the highest value here, which is A. So, and 2 others here, which is BC. So we use these orders 0, 0, 0, 1, 1, 1, and 1, 0. Oh, sorry, should be, I don't know where I put 16, should be just 8, right? So let's start again. You have a function with 3 variables. So you want to use the K-map and get the simplest form of this function. So the function has 3 variables. The K-map should has just 8 squares. So this is a K-map. So the A here could be 0 and 1, and each midterm has a number, right? For example, A here, D is a square, A is 0, BC is 0. This should be 0. Similar, this should be 1. This should be 3. This should be 2. This should be 4. This should be 5. This should be 7. And this should be 6. So then back to here and see which midterm that you have. So in that midterm, the function is 1. So you have 0, you have 1, you have 2, you have 4, you have 5, and you have 6. Okay, you have 6. So again, the member inside the group could has just 1 member, 2 member, 4 member. All the time go with this way: 4 member, 8 member, 16 member. So definitely your K-map is just has 8 square, definitely it's not the case. So you need to start with the 8. So the question is here, could we make a group with the 8 members, with the 8 1? So definitely the answer is no. If you had 1 1 here, you could actually have one group with the 8 members, okay? Forget about the A. So the next groups that you are looking for is the group with the 4 members. So do we have the group with 4 members? So the answer is yes. You could consider these, actually they are neighbor, right? So these 4, all these 4 is neighbor, which is the group with the 8 members. And you could, don't tell me this is just 1, because you could have some common ones and make a group with more members. You could say this is 2, which is the neighbor with these 2 that you have here. So you just put these like this, which is, this is a group with 2 members, 2 is here and 2 is here. So that means 2 group with 4 members. The answer is right. So then write the corresponding term for each of these. So here, let me start with these first group, which is 2 here, 2 here. Write the corresponding term for that. So you are here and here you have 2 member here, 2 member here. Let's see, whenever you move here, what is the change for A? Here A is 0, here is 1. No A in the corresponding term. So here B is 0, here the B is 1. 0, 1, it's gone. So that means no B in the corresponding term. How about C? C here is 0, here is 0, so that means you will have C prime plus. And the corresponding term for this group that you see, okay? That means midterm 0, 4, 1, 5, okay? So if you write the corresponding term for this, again, A here is 0, here is 1, A is gone. So the B here is 0, here is 0, you should have B prime. And how about C? C here is 0, here is 1, 0, 1 will be gone. So that means C prime plus B prime will be the simplest form of these functions. The first group is this one, which is 2, 6, 0, 4. Is it right? 2, 6, these 2, and 0, 4, okay? So I'm writing the corresponding term for this. You check the X. No matter you are in these 2 or these 2, what is the range of the A which is changing? Here, A is 0. Here you comes here, A is 1. 0, 1, there is 0, 1, there is no variable. So that means this A is gone. So that's the reason here you don't see the A, okay? So back to the B and C. So again, you have these 2 and these 2. Just whenever you are here, B is 0. Whenever you are here, B is 1. Again, B changed from the 0 to 1. There is no B here, okay? Again, back to the C. Here, the C is 0. And here, C is 0. 0, 0 will be prime. So that's the reason you got is prime. So, does it make sense so far? Okay, so let's write the second one, which is the group of, this is your group. So midterm 0, 1, 4, 5. Okay. Yes, 0, 1, get rid of that. 0, 0, get the prime. 1, 1, no prime. Yeah. Or 0, 0 or 1, 1, you keep it. 0, 0, get the prime. 1, 1, actually no prime. So see, I actually somewhere summarized that for you. So 0, 0, get the prime. 1, 1, no prime. 0, 1, 1, 0, that's gone. Okay. Okay. So just to finish this. So for this here, the A is 0, 1 is gone. There is no A here. And B is 0, 0 got B prime. And C 0, 1 is gone. There is no C in this term. Okay. So start with one example. So suppose you, again, that is the function with 3 variables. Okay, so function is this function that you see is we have function f, which is a function with 3 variables, x, y, z, and it is equal to sigma m and 2, 3, 4, and 5. So as usual, you actually have 3 variables. The K-map should has 8 squares. So you actually make the K-map with the 8 square. So for each of them, you put usually x here, y, z here, and we usually put 0 here, 1 here. This should be 0, 0, 0, 1, 1, 1, 1, 0. Select the other color for putting the name of the midterm for each square that we have. So this should be 0, this should be 1, this should be 3, should be 2, this should be 4, should be 4, this should be 5, this should be 7, and this should be 6. So just put the 1 wherever we have the midterm. So we did all of them in our last class. So just I don't explain too much because you already know how you could do that. So just take a look to whatever you have here inside the parentheses. That is midterm 2. So you put here 1. Midterm 3, you put 1 here. And midterm 1 here. And 1 here for midterm 4, which is 2, 3, 4, and 5. And the question is how we could group the all ones that you see here. So help me to make the group. So could we make a group with 8 members? Yes or no? 8 groups? No. So that's right. So if you need to do 8, you should actually have 1 in all here, 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 that able to make one group with 8. So after 8, you should have check 4, right? So could I make a group with 4 members? Could we have a group with no? Why? Because these two is not neighbored with each other, right? You couldn't have 8. If we had here, you could actually select these 4, but here they are not neighbor. You couldn't put inside one group. How about 2? How many 2 we have here? How many 2? How many group 2 with 2 member? Yeah, 2 group of 2, that's right. So to just select other color and put these together. So this is 1 and this is second one, okay? So we make sure the number of the group is minimum, their member is maximum. So that means it should be lead us to the simplest form that we have. So first, tell me what is the corresponding term for this group that I put the star here. What should be the corresponding term for this group? Type on the chat box. What is the corresponding term for this group that you see? You could actually open your microphone and also tell me what is the corresponding term related to this. So as I mentioned, you check the x whenever it is just 0 or 0, 0, it gets prime. So that means here you have x prime. Okay, that's for x. Y here is 1, here is 1, so should be y. Should be 1. How about z? Z here is 1, 0, there is no z in this term. Plus. How about this? So check the x. X is 1. And how about y? Y is 0, 0 should be y prime. And how about z? Z still is 0 and 1, so 0, 1 is gone. So 0, 0 is prime, 1 is no prime, and 0, 1, 1, 0 is gone. So that means that should be the corresponding term that we have. So let's have the next example. So have function f. So this time function f is x, y, z equal to sigma midterm 3, 4, 6, 7. Okay, 3, 4, 6, 7. So the question is simplify. So you have three function. So sorry, you have three function with three variables. The K-map will be 8 square. Okay, so this is your K-map. So we already did. So this is x, you put y, z, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So here is midterm 0, here is midterm 1, midterm 3, midterm 3, midterm 2, midterm 4, midterm 5, midterm 7, and midterm 6. Then just take a look to then okay, so then you just take a look to whatever you have here, which is midterm 3. You have 1, you have midterm 4, just put 1, 6, put 1, and 7. Okay, so we actually got something like this. So tell me, how do we have a group again? I start to test in this way. So see, group could be has 1 member, 2 member, 4 member, 8 member, 16 member, 32 member, 64 member. So definitely these are not the case. The only thing, the maximum we could have is 8 members. So could I make the group with 8 members? Yes or no? Definitely the answer is same, right? So that means, sorry, the answer is no. So that means here, if you have all 1 in all places, you could actually select one group with the 8 members. How about 4? Could I make the group with 4 members? The answer is no, because these 4, 1 is not actually adjacent or neighbor. You couldn't put them inside the one group. All members inside the group, they should be neighbor, okay? So that means we refuse that too. So then back to, so I don't have 4. How about 2? So I have 2. So this is 1, 2, which is somehow obvious. How about the next one? Do I have any another one? Do we have any another one? So the answer is yes. So see, as I mentioned in last class, consider this K-map for 3 variables, something like this. So which is this member is neighbor with this. That means 2 and 6 is neighbor with 0, 1. So that means you could consider these 2 as a one group with 2 members. Okay. If you have, yep, okay, you're good. So here we have just two group. Each group has 2 members. So then you need to write corresponding terms. So see, I'm writing the corresponding term for 3, 7. So this one that you see, x is 0, 1, it will be gone. The y here is 1, z is 1. So x, y, z, the both is 1. So it should be y, z plus. How about these two? So here x is 1, here x is 1. So we have x. So how about y? Y here is z, here is 1, 0, 1 gone, and z here is 0, here is 0. You have z prime, okay? So that means y z plus x z prime will be the simplest form of the function.